To begin with, we shall be looking at a specific set of questions from the Gauteng province, but not only from the Gauteng province. I'll also have once again questions from other provinces as well. Okay. We shall start with the questions you brought. I know that they are pretty straightforward, but it will help to navigate through the questions and make sure that we can answer the questions. You brought a question that focuses on question 2, and right. In the diagram, PQ is the diameter, etc., and we need to prove this result. I have made enough space available on the other side um, of the screen. Right, so in the diagram, if PQ is a diameter of this circle, we realize P is actually over there and Q is over there. If this is a diameter, you're able to see that it obtains an angle of 90 degrees at the circumference of the circle. In the diagram, you have the diameter PQ. PQR is a straight line, so you have PQR is straight. Right, and QR equals QS. So you do have that obviously QR equals QS, and they're both X. So you made them X there obviously already. And now we just have to prove that RS equals this result. So we're interested in finding the length of RS. But first things first, we can see that we also have that QPS, QP. S equals the angle theta at the circumference of the circle. So what is therefore the meaning of these here? It means therefore, if we write the solution, we first realize therefore that angle Q2 is equal to what? Is equal to 90 degrees plus theta. Why? Okay, that is one thing that you need to do to get the result that the lecturer wanted, the teacher wanted. So this is the case because the exterior angle of triangle equals the sum of the interior opposite angles. Okay, if this is the case, what do we get next out of these? What do we get next out of these? Right, so we need right now to actually work in a specific triangle. So we're going to work in triangle. Right, we're going to work in triangle QRS. Right, working in triangle QRS, we have the triangle here like this, and here it is. This is X and that is F. X, this is Q, R, S. Q2 90 degrees plus X. Okay, so if we want to find RS, we use the cosine rule. So we have RS squared will be the same as X squared plus X squared. So in other words, RS squared will be X squared plus X squared minus twice X and X cosine of the angle there. And this is actually Q2, from which we're able to see that RS squared equals, okay, X squared plus X squared gives us what? Gives us exactly 2X squared minus X by X gives us exactly X squared, the cosine of the angle Q2, which is 90 degrees plus theta. RS squared, which is 2X squared minus 2X squared. In which quadrant is 90 plus? Is in the second quadrant. In the second quadrant, the cosine itself is what? Is negative, but it changes to the cofunction, and the cofunction of the cosine is the sine of theta, meaning RS squared is the same as twice X squared. Negative by negatives gives us plus twice X squared, the sine of the angle theta, from which we're able to obtain by factoring out X squared as a common factor there. Right, we shall have within the brackets, or we can factor out 2 x squared, and then we have 1 plus the trigonometric sine of x, the trigonometric sine of x, right, from which we're able to achieve a couple of things. Right, so we're able to get that this here is the same as the sine of theta. So we take the square root on the left, and we have rs squared. We apply the square root on the right, and we have 2x squared into 1 plus the trigonometric sine of theta. And the meaning is, if we deal with this here, the square root of rs squared becomes only rs, and the square root of 2x squared here. Right, so that one you can write as the square root of x squared into 2. Right, so you can write the square root of x squared into 2, from which we're able to get the following. Right, so it is the square root of x squared into 2. Right, so it becomes the square root of x squared into 2 into 1 plus the sine. 1 plus the sine. This way, from which we have rs. The square root of x squared is only x, and then you are left with the square root of 2 into 1 plus the trigonometric sine of theta. All right, so that is the answer to the question. That is the answer to the question. So we continue.
Yes, sir.
All right, next question. So we got the result because we have to prove that rs equals x into that. Right, the next question I received from you, I decided to spend some time on it just to discuss with you, but obviously we shall look at inter-provincial questions that featured in this year's prelim examinations. Right, in the figure, you have the information given. You have to prove that KL equals this, where KL is actually that one. Okay, I decided to break the question down into digestible pieces. And so I decided to put the shape there, but we have to prove this result. In the figure, we have K, M, and L are 3 points in the same horizontal plane. There's K, there's M, and there's L, the 3 points in the same horizontal plane. The angle, KLM is 120 degrees. This angle here, K, L, M, obviously this is wrong. Okay, it must be KML. Okay, examiners don't do this. Right, so the examiner made a mistake there. So clearly that must be the angle KML, which is 120 degrees. So examiners don't do this because the examiner just to actually put KLM instead of putting KML. Right, so T represents the position of a point directly above K. Okay, there is T up there. So that TK is equal to LM. Right, there's TK equals LM, and this is Y, and that is Y. TKM, right, so there's TKM equals 90 degrees, but there's also TKL, which is also 90 degrees. All right, so I'm glad that you have shown the 2 angles of 90 degrees there. Okay, so the angle of elevation of T from M, the angle of elevation of T from M is theta. There it is. This angle is theta. There it is. And therefore, we need to just prove this result here. Right, so to prove KL, we shall be in a position to proceed with ease there. Right, we shall be able to proceed. So first, to prove KL, what do we use? We use any of the results, right? Because here is the K and here is the L. This one is exactly Y, but we just need one side, okay? Because we're going to use the cosine rule, because you can see the hint is there's already a square root. We're going to use the cosine rule because we have the included angle, but we just need this side here. So we'll need to use this one here, right? So we're going to work first in triangle TKM, right? So in triangle, right, TKM. What do we have in that triangle? Right, so what we have in that triangle, we have exactly that. But now this angle is theta, so yeah, you're right, this one is theta. So we're going to be in a position to find that one, but we have the opposite, and we're interested in the adjacent. In view of SOHCAHTOA, we have the opposite. We're interested in the adjacent. Opposite adjacent is the tangent, so we shall have the tangent. We have the tangent of theta, which is the opposite, which is actually y over the adjacent side, and the adjacent side is clearly km. Is clearly the side km, from which we're able to achieve km, right? By cross multiplication, we cross multiply, km sits here, and the tan will sit at the bottom. Now the tangent here sits at the bottom of the fraction, okay? In which case, we obtain the expression for km there. Right, next thing, now we're in a position to actually work in this triangle over here, right? So this is therefore straightforward, in which case, therefore, we'll tell the examiner, that means the examiner, we now gonna work in one triangle, so you're gonna work in triangle KML. Okay, right, so what is this? We're interested in finding KL, so we know therefore that KL squared will be the same as what? Right, so KR squared, you have y, and this one, this side here, is y divided by the tangent of theta. In which case, therefore, it becomes y squared. So the KR squared equals y squared plus actually y divided by the tan of theta, the tan of theta squared, right, minus 2 in view of the cosine rule. Right, you multiply the y here, and then you multiply by you multiply this and that, the y, the tan of theta, and then you have the cosine of the angle included, 120 degrees. 120 degrees, okay? So we have exactly that one. In which case, therefore, we have KL squared. What is KL squared? It's exactly y squared plus y squared divided by the tangent squared of theta minus 2y squared divided by the tangent of theta. What is this now? The cosine of 120 is the same using reduction formulae. It's 180 degrees minus 60 degrees, because this is clearly 120 degrees. In which case, therefore, we have KL squared, which is the same as y squared plus, right, we have y squared divided by the tangent squared of theta minus, so here this one is exactly 2y squared divided by the tangent of theta. In which quadrant is 180 minus? Is in the second quadrant, and the second quadrant the cosine is negative, and then you just write cosine and the acute angle 60 degrees, in which case we have therefore the KL squared, which is the same as y squared plus y squared divided by the tangent square of theta. The negative by the negative becomes a plus. You have exactly 2y squared divided by the trigonometric tangent of theta. Right, so the cosine of 60 degrees is 1 over 2 from the special triangles, and we have this result here. Right, from this, we're able to see that KL squared is the same as right, y squared plus y squared divided by the tangent squared of theta, plus now you have y squared divided by the tangent of theta. Okay. Right, so out of this, we continue there. We divide the whiteboard so that we can proceed further to the right-hand side of the board. And we have this. Now we clearly see that there is y squared, y squared, y squared, which is therefore a common factor. Right, with that common factor, we have 1 over the tangent squared. So we have 1 over the tangent squared of theta. And then we have the tangent of theta plus 1. Right, from which now we're able to take the square root on the left and the square root on the right-hand side. So we apply the square root sign on the left of the equation. Furthermore, we apply the square root on the right-hand side of the equation. And we have the tangent squared of theta. We have 1 divided by the tangent of theta. Right, we add a 1 there. Right, so we are in business now. With this said, we are in a position to realize, therefore, that the square root would therefore give us exactly KL. Right, the square root of the y squared becomes a y, and we therefore have the square root of everything else that is sort of irreducible. So we have 1 divided by the tangent squared of theta, and we have 1 divided by the tangent of theta plus 1. Right, and it's exactly what the examiner wanted, and we have the result. Okay, so just to look at the solution and make sure that you understand the solution, because we are practicing solutions of triangles, and we are focusing on the 2 and the third rule, the sine, the cosine, and the trigonometric area formula. The next question. The next question is actually from the Gauteng province or from the province of Gauteng. And we are interested in finding, so it came in the trials of 2023, but we are discussing this specific question. Right, in the diagram below, you have P, Q, and T. There's P, Q, and T. There are 3 points, etc. And so you should show this, you should show that, and that. And I decided to break the question down in the digestible pieces so that we can be in a position to solve it piece by piece. Right, so in the diagram below, P, Q, and T, we have P, Q, and T are 3 points in the same horizontal plane. Right, and MT is a vertical mast. Right, here is MT, it is vertical. Right, and therefore, because it is vertical, it makes angles of 90 degrees with the horizontal. And we have MP and MQ are 2 straight wires. Here is MP and here is MQ. They're those straight wires. The angle of elevation of M from Q is theta. This one here is exactly theta. PQ is K meters. So we have PQ is actually K meters. PM is equal to 2 PQ. You have PM is equal to twice the PQ. Right, so this is extremely important for us. Right, it's extremely important because you have PQ is K and you have PM. Here is P and M and it's twice PQ, which means this one here, PM. Right, so PM is twice PQ, which is twice what is PQ is K, so which means PM is equal to 2K. Okay, 2K. Right, so right, the area of a triangle MPQ is that one there. Right, so we have been given the area of triangle right, M P Q. There it is. Okay, MPQ is exactly that one. They gave it to us. Right, show that MPQ is actually equal to 2 theta. Show that MPQ equals 2 theta, the angle MPQ. So if you look very carefully, there is M, there is P, and there is Q. Right, you need to show that that angle there is actually to theta. Right. So I'm sure that this question is actually very, very straightforward. And so, right. So what do we do here? First things first. All right. So in 7.1, just for 3 marks there. Right. So the couple of hints, and now they've given you something extra. So, for example, if you have been given the fact that this angle here is theta, what would that angle be, for example? Okay, so you explore the diagram. So this angle is theta, this one is 90 degrees. So in other words, this one is 90 degrees minus theta. 90 degrees minus theta. Why is it 90 degrees minus theta? Because now all the angles must add up to 180 degrees in the triangle here. Right, next. What else do we need? Right, what else do we need? Right, so we are actually very much well placed to solve this problem, and we just have to show this one for a beautiful 3 marks. First things first. So, Mr. Examiner, we can solve this question with confidence, and there are too many ways to do this particular question here. Right, so the examiner is saying we need to show that MPQ is twice theta. Okay, easy. Right, so the area of triangle, the area of the triangle, MPQ. Right, the area of the triangle MPQ is actually the same as what? Right, it's actually 1/2. The area of the triangle MPQ is 1/2 into Q, into K to K. It's 1/2 into K twice K into the trigonometric sine of the angle included. What is the angle included by the sides? It's this angle here, and this angle is actually given there. Okay, you need to, it's actually the angle MPQ. So we erase this one here.
Sir?
Yes, please.
So I'm confused. How is the area of MPQ equal to half K if they gave it to us as 2K squared sine
Yes.
theta cos theta?
Yes, okay, yeah, that's a good point you're raising. So in other words, there are 2 ways to find it. Right, so there are 2 ways to find the area. Okay, yeah, you're right. They've given it to us, but there are 2 ways to find it. So, okay, first I'm using the first method because they've already given it to us. But now we need to find the actual area, because if we can find the actual area, then we shall be able to get the result they want. Okay, so there are many ways to do the question. Right, so obviously they've given it to us. Right, but there is an easier way to do the question. Right, so at this point, what I was saying then is, of course, you're right. So you have half K to K, the sine of the angle included, and this angle is MPQ, which is what they want. Right, MPQ. Right, so you have MPQ like this. But I'm glad that you said they've already given it to us. What did they give us as? That one. So it means therefore here in the place of the area of triangle MPQ, we put 2K squared. We put exactly what they gave to us. So sine theta, cosine theta is equal to. Right, so now you continue to the other side of the equation. Right, so continue to the other side of the equation. What do you get? Right, so what you get on the other side of the equation is exactly that. Okay, so you can write in a couple of ways, but you can write it as only because the 2 cancels, so you have K squared, the sine of MPQ, like that. Okay, there are too many ways to do this question, but yeah, this is sort of the method that will be naturally the one to use. Okay, right, so K squared is a common factor here. Right, so if you factor it out, you have 2 the sine of theta, cosine theta, which is K squared. the trigonometric sign of MPQ. Right. So, but what do we know? But Mr. Examiner, we know that the trigonometric sign of 2 theta is the same as what? Is the same as 2 sine theta cosine theta. So we put it here. Right. Hence, this is k squared. Right. Wherever there is 2 sine theta, cosine theta, what do we have? Sine 2 theta. So this is sine 2 theta, which is exactly the same as k squared. The trigonometric sign of MPQ. Right. We divide by k squared both sides, and we get that the sine of this is equal to that. Okay, can you show some step? One step? Yeah. But, right. So you can just show a step here. Okay, so we divide here, so it's k squared. You have the sine of twice theta, which is k squared, the sine of MPQ. You divide by k squared, you divide by k squared. And then we're able to achieve that the sine of 2 theta is equal to the trigonometric sign of MPQ. Okay. So what is the answer to this now? Okay, so we have the answer already. So in the end, what do we achieve? Right, so it means we can solve this one here because we want to solve for MPQ. So we can write the sine of MPQ, of angle MPQ, is equal to the sine of 2 theta. We proceed to decide. Right, in this case, we have the sine of MPQ is equal to the sine of that one. Okay, let me not repeat that one. Let me just write it clearly here. Okay, so we have exactly what we obtain here. So what is this now? Right, what is this now? Right, so we can write this one here. Right, we have this one over there. Okay, so we have this, and then we have that. Okay, good. Right, so given this now, we can take the arc sine on the left and arc sine on the right. Let's just do that. So we take the arc sine on the left, and then we have the sine of MPQ angle, which is the arc sine of the sine of twice theta. Okay, so the arc sine removes, and we have MPQ is equal to twice theta. Okay, but I must agree that there are many ways to do the question. But this is most certainly one way to do the question. And there are lots and lots of other ways to do it. But the area is, it means you must just, because the area has already been given. So if the area has already been given, you can also find it by observation. You know, because you can just manipulate the area. But I think this is much more of a practical way to get the 2 theta. Okay, but once again, there are too many ways to do this question. So you can use many, many methods there. Okay, we proceed. The next question. Right, the next question is also very interesting for just 4 marks by the province of Gauteng. Right, the information we read above, the area was given.
Sir?
Yes, please.
So for the previous question, I'm confused how we got to the 2 theta.
Right. Okay. Here we have arc sine of the sine. Right. What is this if you say arc sine of, because I'm trying to understand your question. Arc sine is like saying 2 to the negative 1 times 2x. What is the answer? Right. If that is your question, I'm trying to understand if that is your question.
Yes, so that's my question. Yes.
Okay. Right. Because if you have 2 to the minus 1 times 2x, right, what you do is it means this is the inverse. So the inverse of 2 eliminates 2, giving us 1 times x. And the answer is x. So in other words, when you have arc sine of the sine of 2x, the arc sine removes the sine because it's the inverse, like the inverse, because you remember that also if you write the inverse of 2, right, now you therefore have the inverse can also be written as 1 over 2. It's the inverse. Right, so these 2 cancels this one, giving us x. So either way, the inverse sign removes the sign, giving us the identity function. Okay, but those kinds of details are mostly preserved for university students because the sign is obviously a function and the number 2 is a number, in which case, therefore, obviously numbers and functions are different in the way they behave and in their definitions. Right. But as you were saying, that the inverse of 2 times 2 gives us 1. So the inverse of sine and the inverse of the sine, right, taken over as a function of the sine will actually eliminate the sine, will remove the sine, giving us sine 2 theta. So as a consequence, therefore, the students in the province of Gauteng were asked to show this question, to just show that MPQ is a 2 theta. And the students would realize that the area was given, it was the hint. Okay, it was the hint because how else can this question be done? I mean, is there any other way to do the question? You can sit down and think. But obviously, if you look at the angle the examiner wants, MPQ, you realize there are no other angles that are given here in this triangle here. So the angle theta is just in the other triangle. So you'd be like, but how does the examiner expect the student to do this? They just have to use the area formula, and that's the only way out of this question. There. Okay, can they use other methods? Yes, obviously there are many other methods. Can we use the cosine rule? Yes, we can use the cosine rule. Can we use the sine rule? Yes, we can use the sine rule. But obviously, this one was the easiest one to use for the 3 marks. I tried to show a bit more steps, but I should have cut out on. I mean, the whole thing could have taken like literally 3 steps for the 3 marks. You know, would have just shown that from the fact that the sine of MPQ is the sine of 2 theta, it means that MPQ equals 2 theta. Because the sine of something equals the sine of something else, it means the angles are the same. Well, it means the angles are the same in the event that the sine function is actually a 1-to-1 function. Looking at the angle to Q, 2 theta is basically mostly an acute angle. Okay, so but that will be very advanced. The questions, the examiners will ask questions that will observe them or sort of behave within the mathematical rules, because yes, the sine can be equal to this, but if the angle is not acute, then the inverse does not exist of the sine function. So in mathematics, we learn, in particular at university, where we study inverse functions, that the inverse function exists for acute angles theta, but not for obtuse angles. Okay, so that is something very, very important. So I can always give some details on that. Okay, I believe that is pretty much clear, but yeah, we can have more discussion on this. Next question. Right, in same question, they continued from the province of Gauteng. They asked the students to say hence. What does hence mean? Right, hence means using some information from above. Show that MQ is this. The examiner now is interested in MQ. Okay, is interested in MQ. So if the examiner is interested in MQ, how do we even find MQ? The giveaway is there's a square root. Because there's a square root, it therefore means that we need to use the cosine rule, okay? Moreover, we remember that this side here is actually 2k and this one is k, and we just need to find MQ there. But we already know a couple of things, that this angle here is 2 theta, and so we are very prepared to do this question with ease. So, Mr. Examiner, in view of the law of cosines, so we shall use the law of cosines, right, of theta. Right, so what do the law of cosines tell us? Right, so the law of cosines are able to give us the result we desire. Okay, so we continue over here. Right, we continue over there. We continue over there. The law of cosines, or the cosine law, or the cosine rule. Right, so first we tell the examiner that, Mr. Examiner, because you want MQ, and actually we can see it opposite the angle 2 theta, and this one here is 2k, and this one is k. The rule that is fit, the triangle that is fitting is triangle MQP. So in triangle MQP. Right, which means MQ squared. MQ squared is the same as what, right? MQ squared is the same as, you can take this side here, is the same as twice k squared. Okay, the same as twice k squared. And then we have this one, which is actually the k squared over here. And now we subtract 2 into the twice k times k times the cosine of the included angle, and it is actually up to theta over there. Okay, so we have that first step there. We're gonna actually not cover a lot of steps there. So this one, we're gonna do it in the least amount number of steps, okay? Right, so we have MQ squared, MQ squared, which equals 4k squared, plus, because you square the 2, you get 4, right? You have the k squared, 2 by 2 is 4k squared, and then you have clearly the cosine of 2 theta. Okay, good. Right, from which now we are in a position, we are in a position to add the numbers, to sort of add group-like terms together, right? We agree that if you add actually 4k squared and the k squared, they both give us 5k squared minus 4k squared, right? The double angle formula for the cosine 2 theta is the same as, so we want to get the sine from the cosine, so we're going to use 1 minus 2 1 minus 2 sine squared theta. Right, from which we have mq squared is equal to 5k squared minus 4k squared. You multiply these two, negative by negative is plus, 4 times 2 is 8k squared, the sine squared of theta. Right, from which we have mq squared equals, what is 5 minus 4 of the k squared? Of course, we get a single k squared. So now we continue. Right, we continue. So this one here is subtract from 5, we subtract 4, we get a 1. Right, and then we get this one here, sine squared that. So which means you have mq squared, which is k squared into 1 plus 8, the sine squared of theta. Right, so this one is straightforward. We are very close to the results, and we can just take the square root both sides. So we have mq squared, square root is equal to the k squared into 1 plus 8. Right, the sine squared of theta, we apply the square root both sides. All right, so this can be written now on the left-hand side, and we therefore have mq. If you take the square root, the square goes away, the square root of k squared becomes k because k is positive, right? So we have 1 plus 8, the trigonometric sine squared of theta, and this is exactly what they asked the students to prove, right, in the province of Gauteng, and the students had to prove this for the 4 marks. And so we have managed to prove this, and using the law of cosines, and we proceed to the next question because we have solved this one. All right, what is the next question? Okay, they went on to ask the students for a further 3 marks from the same province to do something there. Right, they said if you have that k is this one and theta is this, determine the length of mt correct to the nearest meter. So they've told us that theta is actually 42 degrees there. And you have been given that the angle k, or rather the length of the side k, is actually this. So you have been given that k is 139.5 meters. And so what do we do now to determine actually the length of mt? And here is mt over there within the required result. So obviously we can do that one with ease, right? And so I'm sure that that is very, very straightforward. So to find the length of MT, we use the trigonometric ratios because we can see clearly that the triangle here is right angled. So we continue without fear. Right, so we then say in 7.3. Right, so we have the in triangle. Right, so we're going to work in triangle MTQ. Right, so we have we want MT, but also we need to relate that to what we know. We already know MQ there, so we're dealing with the opposite, but the hypotenuse is of interest to us. So we have SOHCAHTOA, in which case we have the opposite of the hypotenuse. Right, opposite of the hypotenuse. So we are opposite the hypotenuse is the sine function, so we're gonna use the sine, right? So we have the sine of 42 degrees, which is the same as, so right, so we have this triangle there, which is the opposite, which is mt over the hypotenuse, which is exactly mq over there. All right, so we get the result. So what is this now? Right, so Mr. Examiner, we actually are able to get the length of mt. Right, because MT is actually equal to that one. But, Mr. Examiner, there are a couple of things we need to know to find MT, because we can cross multiply. So if we cross multiply, MT becomes MQ, the trigonometric sine of 42 degrees. Okay, right, MQ we already know from the previous question, so we just need to copy that one. Right, we proved MQ there. So MQ is actually K times the square root of 1 plus 8, the trigonometric sine or square of theta. So which means that here we have MT only. Right, we have MT only. Right, so if we have exactly MT only, okay, we continue, we have MT only. Right, so MT is actually K times the square root of 1 plus 8, the trigonometric sine squared of theta, times the trigonometric sine of 42 degrees. And we are in business now, which means we can proceed to solve the problem because we already know our K, which is actually 139.5 meters. And we have this one, which is the square root of 1 plus 8, right? And we have this one, which is the sine of the angle theta, which is 42 degrees, times the trigonometric sine of 42 degrees. And T equals exactly the result we are getting here. So now the students, they said correct to the nearest meter. And so let's just quickly do this one. So if we do this one here, it is 139.5 5 there meters, right? You multiply by the square root of 1 plus 8, right? And then you have the trigonometric sine of 42 degrees. And then you square this one here, right? And then it is everything multiplied by the trigonometric sine of 42 degrees. And so we are able to get the result, which is 139.5 into this, the sine of 42, which is 199.80541 meters to the nearest meter. There, which is what the examiner wants, it means MT is approximately 200 meters. 200 meters. And we are done. And this is the result. So we have been able to determine the length of MT to the nearest meter. Okay, now we are done with the questions from the province of Gauteng. Let's see other provinces as well. I decided to bring a question from the province of the Northern Cape. Right, Northern Cape province, they brought an interesting question. Let's have a chance to see what the people of the Northern Cape brought for their students. I decided to look at this question very carefully from the Northern Cape, written in 2023 trial of preliminary exams of the prelims. I decided to look first at 8.1. Right, in the diagram, or the diagram shows a vertical pole, PS, right? PS, the vertical pole held in position by two anchor cables, PQ and PR. There's PQ and PR, their anchor cables respectively. You have S, Q, and R lie in the same horizontal plane. You have S, Q, and R lie in the same horizontal plane. Oh, like the people from the province of Gauteng, they gave the area. And they said the area of triangle QRS is AM squared. Okay, so these here, the area might be given in the coming exam. I have a strong feeling 2 provinces, they have done that. And I've not, these questions, I just chose them randomly. I did not even do them before. I just brought them for us to discuss them. But I can testify that I have a strong feeling the area is very important in this year's November exam in the next couple of days. Right, the angle of elevation from R to P, right, from R to P, the angle is actually X degrees. QSR is actually the Y. You have QSR is Y degrees, and you have that QS is equal to K meters. Right, so we have that QS is K meters. They gave to the students of the Northern Cape province over there. Right, so express right now SR in terms of X and PS. Okay, for just 2 marks, they've given the students something very easy to start with. Let's enjoy together with the people of the Northern Cape. Right, so we want to express SR. Where is SR? Here is S and here is R. Right, in terms of X. Right, so in terms of the angle X, but also in terms of the PS. Okay, so we can do that with ease. So it means, therefore, we need SR, which is the adjacent side, adjacent theta, but we also need PS, which is the opposite. So in other words, we recall that we are dealing with trigonometry. So SOHCAHTOA must come to our minds. And now at this point, we want to find, to connect SR, the adjacent side, right, related to the opposite, right? So if you have the adjacent and the opposite, it is the tangent that relates the 2 sides. And then we have the angle X there. So we have the following, right? So we have the tangent. So first we tell the examiner, Mr. Examiner, we have realized that you actually want us to work in triangle PSR. So in triangle PSR. Right, so we have at this point what? Right, so we have the tangent of the angle X. The tangent of X, right? The tangent of X is the opposite, which is actually PS over the adjacent, which is exactly SR there. And so we are interested in finding SR, so which means therefore we have SR, which is actually PS divided by the tangent of the angle X. And now this here is the one we want, so SR is equal to this. So it means we have found SR in terms of X, but also in terms of the side PS. And that is very much sufficient for the 2 marks there from the people of the Northern Cape province. Let's look at the next question. Right, they then said, okay, students, prove this result right now that you have. So now we're interested in actually looking at the answer to 8.2. Right, 8.2 looks at PS. Right, and we already have PS somehow over there. So, and this relates to the tangent of X. And so now we just need to get to something else. And now it means now, how do we get PS? So recall that. So we don't need to do this one because we already know from the previous question. We recall that PS is equal to, SR is equal to PS over 10x. SR, right, SR is equal to PS over the tangent of the angle X. Okay, so that is what we need to recall from the previous question. After we have recalled that, we are actually in a position to get the result. So we have these. But now they said, okay, now you must make PS the subject out of these. Right, which means that we have PS is equal to actually SR, the tangent of the angle X. What is SR? Right, so SR now is this one here and can be found with ease. But also we can see that they have given us something about the triangle QSR, the triangle QRS. The triangle QRS actually has this area over there. Right, so if this is the case, we can get something out of this, but we can be able to get the side SR because the side their QS is already given. So they love the area, these examiners. So we shall say, but the area of triangle QSR, or we can say QRS, the area of triangle QRS, like the examiner, the area of triangle QRS. QRS, this area has already been given like this. But we can find it as well. Okay, we can start with the given one. So it is AM squared. Leave the meters out of these. Leave the units and deal with the numbers. Okay, but we already know that the area of triangle QRS is also 1/2, right? Is 1/2 the size, this K, 1/2 K is R times the sine of the angle included, which is Y, is equal to A, like this. Okay, so what do we get out of these? So what we get out of these is what? So we can simplify these. We can simplify these here because the area has been given, but we also found the area as well. So now we need to just find SR out of this. So it's very clear we can cross multiply and be able to get that SR is, if you cross multiply, this one becomes exactly twice A. And then you divide by actually the side K, the length of the length K. Right, so we have 2 equations, and Mr. Examiner, these are like simultaneous equations that are arising from this beautiful question from the Northern Cape province. And now we tell them and say we substitute.
Oh, sir?
Yes.
Sir, you lost me after we said the area
Of triangle QRS is A, right? We agree the area of triangle QRS is A square meters, which is, I wrote only A because the square meters are just going to be a disturbance for us. Okay, so we just need to deal with the area. So I've put the area, but obviously now we also, like in Gauteng, need to find the area because we're dealing with QRS, so we're dealing with Q there RS, and so to find the area of this triangle, what do? We must find the area. So to find the area, we say half. We say 1/2 times the length of the included of the adjacent sides that include the angle. So we'll say half K, and also this one is R. So to find the, but you see they gave us the area, but we need to find the area as well. Why? Because the area they've given to us cannot help us now because it appears here. It means that we must get the area as well, because if we're able to get the area as well, then we can be able to get SR from the area. Okay, what is the area of triangle QRS? The area of triangle QRS is half K this times the sine of the included angle. So we say the area is half K times SR times the sine of the included angle, which is the angle Y. Right, so that's what we have over there. Right, so we cross multiply at the end of these. Right, so this is 1/2. If we give you in mathematics, 1/2 X equals Y, you can cross multiply like this. And then you get X equals 2Y. So these two goes there. So in the same way, because it's 1/2, these two will multiply the 2A by cross multiplication, right? After that, we divide by what remains. Okay, let me just do it step by step. Let me do it step by step for you to understand. Right, for you to understand. So now we have these here. We have these here. Okay. Okay, so we continue. Okay, so we cross multiply for now marang. We cross multiply for now marang. So how do we cross multiply? So we cross multiply because we have a fraction here. So this fraction we can write it in many ways, you know. Let me write it in this very standard way. So now this fraction marang, if we want, we can take, because we have the fraction 1/2. So we're gonna multiply both sides by there are many ways. So you can take the number 2, multiply by the number 2 on the left, and multiply by the number 2 on the right. Right, these two cancels this one, giving us K SR, the trigonometric sine of Y is equal to twice A. Okay, we get this. Now we want to find SR out of this because SR must appear. Why do we need SR from the area? Because we can see that the examiner is saying we must prove PS equals this. But now PS has SR, so we must make SR the subject of this equation. How do we make SR the subject of this equation? Right, so we must divide. Right, so how do we divide? So we take the KSR, the trigonometric sine of Y, which equals to A. We divide by what? Right, we divide by K, the sine of Y. But whatever you have done on the left must be done on the right. So we divide by the K sine Y. It means, therefore, we have SR is equal to 2A divided by the sine of Y. Right, so this is exactly the result we want. Okay, right. So now we have this one is actually equation 2 for us, and we got equation 1 there. And now we are in a good position to conclude this question from the province of the Northern Cape, and we have the result. Right, so we have the final result. What is the final result? So to get the final result, we're going to move from here to the other side of the board. And we're going to say, right, let me just erase this one here to be a little bit tidy and to do the following. So I can draw this one here. So we proceed to the other side of the screen, and we get here now. And we're going to say, now you need to put, what do you put? Right, so we need to just take this SR and put it into equation 1. Right, so the word put is very short, formed by 3 letters, shorter than the word substitute. So put equation. Right, put equation 2 into equation 1. Right, if we put now equation 2 into equation 1, what do we achieve? Right, we're able to achieve that in the place of SR, we're going to put 2a over sine y in the place of SR. So which means that we're going to have PS. So what is the SR? Is actually 2a divided by the trigonometric sine of y, right? And then you have the tangent of x, which comes with the equation 1. So we have, therefore, that the PS is the same as what? Okay, right, it's 2a tan x, which is actually what they gave to the students or to the learners. It's 2a the tangent of x, which is actually moreover divided by, okay, remember you divide by, we have a k here. Right, we have a k here. Remember, we have a k sine y, so obviously we have a k over there. Right, so this one is actually a k sine y. So let's look at how far we are. It looks like we got to a, the tangent of x divided by k sine y. For 4 marks there, we're able to achieve the result. And this is what the students from the Northern Cape had to solve this year's trial exams. Next question. Right, so they then said to the students, okay, now that you have found everything, students, find the value of y if you have been given all these things. Right, to do 8.3, you would say, you have to say recall. So you need to remember the past. Right. And in remembering the past, we remember what we got. What was the PS here? It was PS equals to 8 and x. Right. So we have that PS equals to a the tangent of x, which is divided by k sine y, which is divided by k the trigonometric sine of y. Right. So you can have this, you have this now. So we do before we will perform substitution, from which we know PS now. We substitute. So PS is actually 76.8 meters, right, given, equals twice A is 480.9 square meters. So we put 480.9 square meters. Right, we have the tangent of the angle x, which is 46.5 degrees. So we have 46.5 degrees, which is divided by the k. What is k? K is actually, there it is, 87.36. Right, so we have 87.36 meters, and this is multiplied by the trigonometric sine of y, and we have this. Now, what is this here? What is the examiner interested in from the Northern Cape? They are saying, please, learners, find the value of y. So we can see that y is the unknown, and we need to find the value of y. So we have a fraction on the right-hand side of the equation, and we need to clearly perform cross multiplication. So which means that this is going to multiply that, which means we have 76.8, which multiplies 87.36 times the trigonometric sine of y, which is 2 into 480.9 times the tangent of 46.5 degrees over there. Right. Okay, we have this now. So to get the answer, we must move these two guys to the other side by division. So we proceed and say we shall have the trigonometric sine of the following. So we have 2 into 480.9 times the tangent of 46.5 degrees. It is actually divided by these two guys here, and they are 76.8, and it is furthermore multiplied by 87.36. Okay, we get this. We want to get the numerical value of the angle y. So now we move the sine to the other side. And if you move the sine, the trigonometric sine to the other side, we perform the inverse function application. And it means, therefore, we have the arc sine. We call these the arc sine, which is the inverse sine function. And it becomes, therefore, 2 into 480.9 times the tangent of 46 right, comma 5 degrees. You have your parentheses here, and you divide these by 76,8, and this 76,8 is multiplied by the 87,36, and you close your parentheses here, and now we have the result. So it just remains now to move across the screen and go to the left-hand side, and we actually are able to get the final result to this. And how do we get the final results to this? To get the final result, we proceed as follows, right? So we perform the inverse sine computation. And how do we perform the inverse sine computation? So we gonna now just simplify these and get the desired result that we want. Right, so the arc sine right now of the following, let's just get that one is it had to be found. Right, so we have 2 within the parentheses into 480.9, okay. Right, 2 into 480 there 0.9, right, and that is multiplied by the trigonometric tangent of 46.5. And now let's continue to find the trigonometric tangent of 46.5. Okay, and we get that it is divided by the following, divided by 76.8 there, multiplied by 87 in the denominator, 0.36. And what is then the result of this? What is then the result of this? Right, so these can be obtained with ease. And now what is the answer to this? Right, the answer to this can be obtained, and I need to just have that one found. Just a second, let's just get the answer. Right, we're going to get the answer just now. Right.
So I got 8,68859.
What did you get again, please?
8,68859.
Okay, that's fine, because I wanted to bring my calculator. Okay, it's fine. I'll have to trust you. I'll have to trust
So
you.
I don't know if it's right because y looks bigger than x.
Yeah, that's the thing. Sorry, I need to just let me just bring my calculator, because I need to just make sure we get the correct answer. So because now then, if obviously we have that, let's use this calculator here. Right, so if we use this calculator, for example, what do we get out of this? Right, so let's first write this, and then I'm going to bring the calculator on the screen. Right, so let's, to get the correct answer, just 1 sec. Right, I'm going to use the calculator on the screen to make sure we get the correct answer, just to avoid actually an error. So we have the trigonometric sign. So I'm just transferring all this information to the left-hand side of the screen. Right, so we have 480,9 multiplied by the tangent of 46,5 degrees. It is divided by 76,8, right, multiplied by 87,36, and we close the parentheses like this. Okay, so now I'm just bringing the calculator there so that we are in a position to do the computation. Here's the calculator, and we're gonna do the trigonometric arc sine. Right, so now you need to look very carefully and realize that you need to use the shift button, and you have exactly this one here. So you can do it in a couple of ways. You can first, for instance, do the number 2 times 480. So you do 480.9. You multiply that by the tangent of 46.5. Right, so you have the tangent of 46, right, 46.5, like this, right, and you close there. And moreover, you now continue to perform division. So you divide by, you put your parenthesis like this. So you divide by 76.8. You multiply that by 87.36. Okay, and then you have this. You close here, and you close again, and let's see the result. Right. So what did you get yourself?
8. I got the same thing, sir.
You got the same result. Okay.
Yes.
Right. So I think that is very impressive. So we are able to get the following results that you got. Right. So you got the same result. Just 1 minute. Let me show that result again. Here it is. Right. So right, you got the same results. I obviously believe your answer. And because now we got the same answer here ourselves, I'm just going to write it on the screen just now so that we can have it as well. Right. And you can be able to see the answer even when you are watching during your own spare time. Right. We got that y is actually approximately 8,688 degrees there, which is the value of y. So you can to 2 decimal places or to 1 decimal place. Doesn't matter what you do. You can say, yes, please, my dear. Okay, thanks. Right, 7 degrees. Okay, so that is the answer to 1 decimal place. Okay, just 1 second. I'll be back on the screen. Okay. All right. Okay, that's fine. Okay, thanks, my dear. Okay, we continue. We continue by solving more problems here. Seeing what you are getting. All right, so let's continue, please. Let's continue. Okay, so we have this. Next question. Okay, this one is from the province of the Free State. And I decided to bring this question from the province of the Free State. Why? Because the province of the Free State has a very good history in education. But we need to understand that the province of the Free State is the legislative province of South Africa. In particular, if you look at their city, which is Bloemfontein. Let's continue and let's see what the students had to deal with from the province of the Free State. Okay. In the figure below, Thabo is
Sir?
in the, yes, please.
Sir, the lesson is over, but I can do this for homework.
Okay, you can do this for homework. Thank you so much. Yes, the
Sir.
lesson is over. We can do this for homework. I realize that the lesson is over by about 6 minutes already. Okay, right. So, okay, so you're gonna do it for homework. So I'm gonna just show the question on the screen. So when you watch the video, I'm gonna send you the video in the next couple of minutes. So you're gonna watch the video, do it for homework, and send me feedback. Okay. Right.
Okay, sir.
So obviously this is the question. There you're gonna read about Tabor and everything for 7 marks. You're gonna read the video, pause, and do the question. Right. And I have broken it down here. I had made a space available for us to solve it. There, so you have to calculate the lengths of the AC and AD, correct to decimal places. And now you have also to calculate the distance between the two cars, the length of CD as well. And that is the end of the discussion. So I must thank you for joining us. Right, we'll talk again. We can have a discussion as usual. You suggested Saturdays at 4 p.m., something like that. You let me know if that is going to work for you tomorrow on WhatsApp. It's okay. All right. Right. Thanks a lot. I will send the video in the next couple of minutes, but it takes me about, on average, 30 minutes maximum to send the video because I must upload it first. Okay. Right.
Okay,
So
sir.
yeah. Thanks a lot. We'll talk then about tomorrow. You let me know on WhatsApp about the weekend. Yeah. But thanks. And goodbye, Marang.
Okay, sir. Bye.
Goodbye.